Hello, the problem reads a sandbag is dropped from a balloon which is ascending vertically at a constant speed of 6 meters per second. If the bag is released with the same upward velocity of 6 meters per second when t is equal to 0 and hits the ground when t is equal to 8 seconds, describe the speed of the bag as it hits the ground and the attitude of the balloon at this instant. Which instant? Instant when the bag hits the ground. Okay. This problem is coming from the Engineering Mechanics Dynamics 14th edition by RC Hibbeler. So before we start solving this particular question, let's remind ourselves of the three basic kinematic equations. We are dealing with rectilinear motion. This is motion in a straight line or in a straight path. So the three basic equations are the three basic kinematic equations are we have the first one, which is instantaneous velocity, which is the time derivative of position. Instantaneous acceleration, which is time position of velocity. And when we make dt subject to the formula and then we equate the two, then we have one derived equation, which is a ds equal to v dv. From the three equations, we are going to derive three more equations. And these equations are derived when acceleration is constant, ac, t is equal to 0. We have s naught and v naught. Using these boundary conditions, integrate these equations. On the left, we have, so when we integrate these equations, we have, of course, when we integrate this one here, we have s is equal to s naught plus v naught by t plus half ac t squared. When we integrate this one here, we have v is equal to v naught plus ac t. When we integrate this one using those boundary conditions, we have v squared is equal to v naught squared plus 2ac open brackets s final minus s naught. So let's get back to our problem. So we are being told we have a sandbag dropped from a balloon. Let's draw what is happening, right? This is the sandbag. Right. So what do we have? V naught for this sandbag is 6 meters per second. Okay, at t naught equal to 0, we have been asked to find v, which is v final. Okay, v final at t equal to 8 seconds. So the balloon is ascending at a constant speed. Therefore, its acceleration is equal to 0. At the moment the bag is dropped, it will have an initial velocity of 6 meters per second, but it's going to experience acceleration due to gravity, which is constant. Okay. So we'll go with this particular equation. Our acceleration is constant. So we have v is equal to v naught plus our constant acceleration is just g there, then times t. Okay, therefore v naught will be equal to 6 minus 9.81 times 8. Therefore, our v final at the instant the bag just hits the ground or about to hit the ground, that instant the solution is 6 minus 9.81 times 8. What do we have? 6 minus 9.81 times 8. We have a minus 72.48 meters per second. This negative just shows the opposite direction. 6 is going up while our velocity is pointing down. So this can also be written as v is equal to 72.48 meters per second. Then we put an arrow down like so. So this is the speed of the bag as it hits the ground. And they are also asking us to find the altitude, height. So let's look at the question again. They're asking us to find the height of the balloon at this instant. Which instant? When the bag hits the ground. What do you think would have happened to the balloon at the time when the bag hits the ground? The balloon will have moved, right? So if this was the initial position of the balloon, so we are saying by then it will have moved. It will have moved to a new position. Okay, so let's imagine this was the new position. This was the new position of the balloon. I mean the initial position of the balloon. So imagine this was the initial position of the balloon. Let me just write this properly. So if this was the initial position of the balloon, and then we have our bag, like so. So we are saying this was the initial position when, oh come on, there's no space. So say this was the initial position. So say initial position when the sandbag was dropped. So what do you think will happen when the sandbag hits the ground? Imagine the sandbag hits the ground. Here is the sandbag, hits the ground. So we have this position here when it hits the ground. So when it hits the ground, the balloon will have moved, right? Probably it will have moved to a new position somewhere here. Let's say maybe somewhere there, right? It will have moved. Okay. So it means we have two positions that we are going to be calculating, right? We have this one. At a point when the bag is released, and then we also have this one, okay, when the bag hits the ground. So let's call this H1, and then let's call this H2. And this position is position when the sandbag hits when the sandbag hits the ground, right? Great. So therefore, the attitude of the balloon at this instant, so we'll say the attitude of the balloon. So okay, the attitude of the balloon is going to be equal to h1 plus h2. All right. So let's find h1, right? So h1 is just going to be equal to h1 will be equal to which equation do we use here? Of course, we can use this equation, okay, is equal to S naught plus V naught T minus, because our G is minus in our case, T squared. Okay, so H1 therefore will be equal to S naught. This is our reference, so this is our reference, okay, this is our reference. So we have this becomes a 0. V naught is given to us, it is 6. The time is 8 minus half by 9.81 by 8 squared. Therefore, H1 when the sandbag is released is equal to, that's 6 by 8 minus 0.5 by 9.81 times 8 squared. This gives us minus 265.92 meters, right? Then H2 is going to be equal to, when the bag hits the ground, this is the sandbag. When the sandbag hits the ground, the balloon will have moved. Mind you, the balloon is moving at a constant speed of 6 meters per second, and when you have constant speed, constant velocity, what happens to the acceleration? Acceleration is 0. So we have S naught plus V naught minus half g t squared, and because, let me put plus half a squared, a t squared. So this part is equal to 0 because the velocity is constant. This part also is 0, that's a reference point. Therefore, H2 is just going to be equal to 6 times 8, and this is equal to 48 meters. So the attitude therefore, the attitude of the balloon, okay, is equal to H1 plus H2. Okay, so this gives us attitude equal to when we add the two again, we are adding the modulus values. Don't mind about the direction. This is so you can write this again. Don't mind about that negative. Let me just move this down like so. So this H1 just simply means, this H1 here just simply means we have 265.92 meters and it's going down, okay, while this one is going up. Okay, so when we add the two, so we have 265.92 plus 48. This gives us a 313.92 meters. So this is the total altitude when the bag hits the ground. Okay. All right. So let's outline the solutions. So we do have our velocity there. We have our final velocity when the bag hits the ground, and the total altitude of the balloon when the bag hits the ground. Right, so I hope this video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.